Everyone, good to see you again. This is Deepak Krishna VM, ME Structural Engineering AMI, a verified educator from an academy. So welcome back. So today we are going to see how the lightweight concrete is classified generally based on some factors. Okay. So before that, don't forget to subscribe to the YouTube channel of an academy and also follow us through the other platforms like Facebook, official app, and the website of an academy. So let's see how the concrete is classified. Hello everyone, good to see you. Hope you're having a good time. So previously we have seen an introductory lesson on the lightweight concrete. Okay, we have seen some of the basic facts about the lightweight concrete and also some of the small applications of lightweight concrete in general. Okay, so in today's lesson, let's see what are the general classifications of lightweight concrete. So welcome to today's lesson, the lightweight concrete, the general classifications. All right, so first and foremost, without wasting further time, let's dive into the topic today. So the classification, okay, it should be based on some parameters. All right, so in the lightweight concrete division, the classification are generally based on method of production, purpose for which the concrete is to be used, and based on density. Okay, the method, the purpose, and density of the concrete are some of the major parameters for the classification of lightweight concrete in general. All right, so let's see one by one. First and foremost, by the method of production. Okay, so from the method of production, one of the classification is lightweight aggregate concrete. All right, so from the name itself, we can understand that these are kind of concretes that are made out of lightweight aggregates. Okay, so these are not normal weight aggregates. These are more porous material. These are more lighter in weight, and also these are more lighter in use. All right, and also in density also. So most of the specific gravity is lower than the 2.6 value. Okay, which means that the average density, specific gravity of lightweight aggregate are much lower than the average value of the ordinary aggregates. All right, so some of the basic lightweight aggregates that are used are sintered flash, pumice, perlite, bloated clay. Okay, so these are some of the general examples of lightweight concrete. So some of the major producers and consumers of the lightweight concrete are USA, UK, France, and Germany, and other first world countries. So why they are the major producers and consumers? Because they are the place where there is a large scale artificial industry is going on. So we can say that so a lot of artificial, what can we say, aggregates are available in such places. So India is also catching up in those places. So there is a plenty of availability of artificial materials and artificial aggregates. So here also the lightweight aggregate concrete industry is also booming up. Okay, and so that's all for lightweight aggregate concrete. So since the aggregates are so light in weight, these aggregates are porous in nature, so there is a chance of permeability. All right, and there's a chance of permeability because of the porous nature of the aggregates, and also because of this porous nature, the steel used inside can also get corroded because of the because of the intrusions due to the porosity. Okay, porosity of aggregates. And also there is a chance of shrinkage, but shrinkage won't be much matter because the capillary action won't happen much because of the wider cracks inside. So these are some of the precautionary points that we need to keep in mind while we are working with the lightweight aggregate concrete, and appropriate methods has to be adopted to counter all these effects. Okay. Now let's move on to the next one, that is the aerated concrete, another concrete based on the the method of production. Okay, so aerated concrete. So first and foremost, so what is aerated concrete? So these are concrete that are made by introducing large voids within the concrete or mortar mass. Okay, voids should be clearly distinguished from the extremely fine voids produced by the air entrainment known as aerated, cellular, formed, or gas concrete. All right. So that means that there will be two types of voids present inside, the introduced voids and also the voids from extremely fine voids due to the air entrainment. So this has to be distinguished, and also these voids should not be come in contact. So if they come in contact, there will be internal stresses will develop, which increase the porosity of the concrete. Okay, which ultimately result in the lowering of the strength. So this is one of the points that when we discussed during the high strength concrete. Okay, so high strength concrete is some kind of concrete that doesn't allow or doesn't support the practice of aerating the concrete. So while we're working with an aerated concrete, we have to be very careful about the proportioning of the induced air. Okay, so this is one of the lowest density. This has one of the lowest density and the thermal conductivity and low strength. Okay, so this has a very low density and low thermal conductivity and low strength. Because of the low thermal conductivity, it can be used as an insulator. Okay, so that's why this is mainly used for the insulation purposes, and also some of the light practices, that means doesn't require much strength, such as roof screeding and pipe lagging. So these are some of the practices that which applies the aerated concrete. Okay, and the major producers and also the consumers of the aerated concrete are the Scandinavian countries. Okay, all those Balkan areas, Sweden, Denmark, Italy, whatever there are. Okay, so almost all the Scandinavian countries are one of the major producers and consumers of the aerated concrete. Okay, now let's move on to the no fines concrete. Okay, these are produced by omitting the fine aggregate from the mix to develop the interstitial voids. Okay, so the interstitial voids are developed, and also the coarse aggregates used are the normal type coarse aggregates. Okay, so these are used for the cast in situ external and internal walls, load bearing and non-load bearing walls. Okay, these are some of the applications of no fine concrete. The coarse aggregate size varies from 10 to 20 mm. Okay, so this is the coarse aggregate range they usually prefer for the no fine concrete. And also from the name says that there is no fines in it, which means that almost all the fine aggregates are discarded in this. Okay, so comparing all the three, okay, that is the lightweight aggregate concrete, aerated concrete, and no fine concrete. Okay, so lightweight concrete and lightweight aggregate concrete and aerated concrete are the ones that are more widely used than the no fine concrete when comparing all the three together. Alright, now let's move on to the next classification, that is classification based on the purpose. Okay, so the first type is a structural lightweight concrete, which is classified as based on ASTM C33082A. So structural lightweight concrete. Okay, so structural lightweight concrete, from the name itself we can say that this is used for structural purposes. Okay, and it is also a lightweight concrete. Okay, so this classification is based on the minimum strength. Okay, so the minimum strength for 28 days should not less than 17 megapascal. So the minimum strength for this concrete should be 17 megapascal. Alright, and the density of this concrete lies within 1400 to 1800 kilogram per meter cube range. And this is almost like a lightweight aggregate concrete. Okay, so the properties are almost similar as lightweight aggregate concrete. These are used for the structural purposes. These can be used for the manufacture of the elements of the load-bearing structures. Okay, the next one we are looking at is the masonry unit concrete, which is defined by ASTM C33181. Okay, so the minimum strength for 28 days is the 7 to 14 megapascal. So the 7 to 14 megapascals are the minimum strength required for a masonry unit concrete. Okay, and the density for this is 500 to 800 kilogram per meter cube. All right, and as the name suggests, these are mostly used for the masonry works. Okay, and also some of the other plastering on masonry works like roof covering, water resisting coating, etc. Okay, so the name itself is self-explanatory for this concrete. These are mostly used for the masonry works. Now let's move on to the next one. So that is the insulating concrete, which is defined by ASTM C33281. So insulating concrete has properties almost similar to the aerated concrete. So lower density, lower strength, and also low thermal conductivity. Okay, so because of this low thermal conductivity property, this is again mainly used for the insulation purposes. Okay, so it's a very good insulator, so it's used for the insulation purposes. Now let's move on to the classification based on the density. So first and foremost, the concrete based on the classification of density is the low density concrete. Okay, name itself you can understand that this concrete has the lowest density. So the minimum strength for this concrete in 28 days is 0.7 to 6.9 megapascal. Okay, and the density will be maximum. That means at most density will be 800 kilogram per meter cube. So no, this type of concrete won't cross this limit. That is 800 kilogram per meter cube. Okay, so another characteristics of low density concrete is that it has low unit weight and high heat insulation values. Okay, that means that the unit weight of this concrete is less. That means that the dead load of the entire structure will be low, and also it has high heat insulation values. So where it is used? It is used for insulation purposes, temporary walls, low scale partition walls. So all these places, low density concrete can be used successfully. Next one is the moderate density concrete. This is a concrete that which lies in between high density and low density concrete. So the minimum strength for 28 days will be 6.9 to 17.3 megapascal. So these are moderately good compressive strength. That means that it has fairly an average compressive strength. Okay, so this can be used in the very domestic purposes also, without much care to be taken. These are used as filler concrete. This can be used in the shear walls. This can be used for the small coverings. Okay, so the insulation values of this concrete is average. Okay, so as I said before, this is widely used for the domestic purpose type, the domestic purposes, because it has a value of, it has a average value for insulation as well as an average value for strength. So it's a kind of a rounded type of concrete, you know, it can cover almost all the places, but in an average value. Okay, so that's it. So next one is the structural concrete. Okay, so this is the concrete that has the full structural efficiency. Okay, so these are made out of very strong aggregates. This aggregates that lies in the strongest spectra of the strength. Okay, so the compressive strength is starting from 17.24 to 30.45 megapascal and excess. Okay, so 34.5. Okay, so this 34.5 is not a limit. Okay, a lot of cases the compressive strength of structural concrete goes above 34.5 megapascal. Okay, so this has the greatest unit weight among the three types. Okay, which means that the higher strength aggregates are used, there will be therefore the unit weight is more for this type of concrete. Okay, and also it has better thermal insulation values than the normal weight concrete, and has a moderate density concrete. So this has this is more thermally insulated. This is more thermal insulated than a normal weight concrete, and also moderate density concrete. So among the three, this is one of the strongest and best thermal insulators. Okay, in this classification. So that's all for today. Thank you for listening. Please comment your suggestions. Please rate my presentation. Please recommend and share the slides. This is my link to the Unacademy platform. Copy this in your browser. You can see the courses that I've put forward in my profile. Okay. So thank you once again. Thank you so much for being a good listener. I wish you a great day. Until next time, cheer.